Now we have the option to define beams and ribs eccentrically to their logical axis, and this is available for line elements. The first type of eccentricity which is being showed currently is the uniform offset. In this case, the eccentricities are constant along the member and can be set by radio buttons representing selected points of the cross sections, or we can choose to manually give eccentricity values measured from the logical axis of the cross sections. So local X and local Y and local Z values can be defined for eccentricity. The next option is to set the eccentricity automatically by aligning to an eccentricity group. In this case, the E, Y, and EZ eccentricities of the element smallest in the respective direction will be set to 0, while other elements will shift so that their selected point on the bounding rectangle remains. This is suitable, for example, defining tapered members like on the example. And lastly, or not lastly, but the next option is when we align a member to another member, which is a common case when, for example, a beam sits on top of another one. And in this case,
we have to select the members which we want to make eccentric, and then select the reference members on which the eccentric members will sit on. The eccentricity will be set based on the height of the reference members, both on start and end points. In this first example, we have a tapered frame where we will use the uniform offset function. We will use it to set the top flanges of the members for the eccentricity reference, and by this we are able to align the outer flanges of the beams and columns properly.
Next, we have a multi-story building where we have ribs connected to the domains. And these ribs are defined between the columns. Each rib have tapered start and end sections. And using a simple click on the rib eccentricities, we are able to set the upper plane of the ribs to align with the upper plane of the domains. Eccentricities are adaptive in a form that if there are changes in the connected members' cross-sectional or positional properties, it will be adopted by the positioned eccentricities also. So for example, here we are changing the cross-sections of different members, and as you can see, the eccentricities changes properly and updated properly.